Hello, everybody. Today we are going to be covering lesson 4.4. Hopefully you had time to look over the content before reviewing this lesson. If not, I highly recommend going over that content. It provides you good learning opportunity and good place to practice. So we're doing 4.4. If you're looking at my PowerPoint notes, one of the first slides I provide for you are the formulas for the area. You're allowed to use the formula sheet on any assessment. If you haven't found it yet, it is in our class content. There's a tab over here called Geometry Formula Sheet. And in that is a PDF of what the formula sheet on the SOL would look like. You are allowed to use this formula sheet on any assessment. So maybe print it out, make sure you're familiar with it. Has all the formulas there for what I'm about to talk about. Okay. So we're going to practice finding areas. In this shape, I have a parallelogram. So I would look at my formula sheet and I would look for the parallelogram. Here it is. The area for parallelogram says B times H. And if you're not sure what those stand for, they're labeled in the picture. The B stands for the base and the H stands for the height. Remember that the height is always perpendicular to the base. So here's our height. It is making a right angle. It is perpendicular with the base. So in this example, we would write area. And I'll just write the formula here for us, B times H. The B is 12.9, and the height is 7.1. So you can use a calculator, multiply those together, 91.59. Now we're finding the area. So when we find the area, our units are squared. So this will be inches squared or square inches, same thing. Simple as that. And you're allowed to use that formula sheet on an assessment. So you really don't need to memorize this. Just plug in the numbers and calculate your answer. Here I have another parallelogram, but this time its height is on the outside, and that's okay. I mean, I could put the height here if I wanted, and it would still be 16.1. They just have the height labeled on the outside. The base is 11.8. So we'll plug that into our calculator. 11.8 times 16.1, get 189.98. Our units are meters, so for our area, the final unit will be meters squared. The next example, this is no longer a parallelogram, but this is a trapezoid. So we'll look at our formula sheet. And the area of a trapezoid is 1/2 times the height times the sum of the bases. So I will add the bases together. Area equals 1/2 times the height times base 1 plus base 2. So our height in this case is 5. And I'll add the bases together. And you can put this all in your calculator. 5 times 20 is 100. Half of 100 is 50. Our units are millimeters squared. Moving on. He wants to know, what is the exact height of the rhombus? So the height of the rhombus would be here, a line that is perpendicular from base to base. It's not drawn there. However, it is here. AP would also be the height. That would be the same distance as if I had drawn the height in over here. So if it says what's the exact height, well, we're going to calculate the distance between A and P. So let's do that. So we want to find the distance between AP. So now we need the distance formula. Okay. So just a little review of our distance formula. It's the square root the difference of our x values squared plus the difference of our y values squared. So here I have an x and a y, and P has an x and a y. So we x1, y1, x2, y2. We'll plug that into the distance formula. -3 minus 0.2 squared plus 2 minus -4.4 squared. When I do minus and negative, I'll make that a plus because I know that's adding. If you don't like that, you're welcome to leave it minus and negative. You'll get the same answer. Let's see. -3 minus 0.2 squared is 10.24. 2 minus -4.4 is 40.96. When I add those together, 51.2. So the exact height is 51.2. If I had asked you for a rounded height, you could say that's about 7.15. All right, then it says, what is the exact length of the base? So the length of the base would be DC or AB. So let's calculate DC. Okay, so this will now be my x1, y1, and this will be x2, y2. Using the distance formula again to find a length, this will be 5 minus 13 squared plus -2 minus 2 squared. 5 minus 13 is -8. -8 squared is 64. -2 minus 2 is -4. -4 squared is 16. So this is the square root of 80. Because it wanted an exact length, I'm going to see if I can reduce this radical. Well, 80 can be broken into, let's see, 8 and 10. Neither one of those are perfect squares. But 8 could be 2 and 4. 10 could be 2 and 5. So I'm actually breaking this down into the prime factors just because I didn't start with any perfect squares up here. If you recognize the perfect square right away, that's great. 2 times 2 times 2 times 2 times 5. So this becomes 4 root 5. Okay, 1, 2 left the house, 1 canceled out. The other 2 left the house, 1 canceled out. That's where my 4 came from. What is the area of the rhombus? So we would look at our formula for an area of a rhombus. The area of a rhombus is base times height. Wait, Ms. Grandy, that's a parallelogram. Yes, but a rhombus is a very special parallelogram that has congruent sides. So we can use that equation, base times height. We know the base is 4 root 5, and we know the height, I'm going to use the exact height, square root 51.2. So this was the length of the base. This was the height. So the area is 4 root 5 times the square root of 51.2. And I'm going to type that whole thing in my calculator without rounding anything. And when I do that, it actually comes out to a very pretty number, 64. It didn't tell me units, so we'll do units squared since we don't know the actual unit. So you may be asking yourself, can I just round to 7.15 and use that instead? And the answer is no. The main reason is it asked for an exact length. And so if you round, you're not giving an exact length anymore. And notice when I type this into Desmos, the graphing scientific calculator that's available free online, desmos.com. If I type this in with the exact length, I get 64. Perfect. If I type it in with the rounded number, I get a number very close to 64, but not exactly 64. And that could change your answer, especially if you have to type an answer in. If you typed in 64, you would get credit for this. But if you typed in the 63.9 or 63.95, you probably would not get credit for it because that's not the exact answer. That's a rounded answer. So if it asks you for an exact answer, just make sure that you are giving an exact answer and only rounding at the very end if needed. The next example says the vertices of a parallelogram are at these 4 points. What's the area of the parallelogram? So let's sketch what this looks like. Oops. Didn't come out the way I wanted it to. Let me try that again. Trying to be fancy with my board. It's not working. All right. 1, 2, 3, 4, 1. So here's one vertice. 5, 6, 7, 8, 9, 10, 1. Here's another one. 1, 2, 3, 4, 5, 6, 7, 8, -4, and 2, -4. I'm going to go ahead and label those just because this is a sketch. And 2, -4. Okay, so here is where my parallelogram would be. And I want to know the area. So I would look at my formula sheet and look at the equation for area. Area of a parallelogram is base times height. So the height would be here, and the base would be the distance here. Okay, you could use a distance formula if you would like, and you definitely may, but you can also go about it a little smarter and know that here, this x value is 4, and this x value is 10. So that distance has to be 6. 1, 2, 3, 4, 5, 6. So the base is 6. The height, you could use the distance formula again, or I know that this is at a 1 on the y-axis, and this is at a -4. So the distance between a 1 and a -4 is 5. And so once I know that, I can just multiply 6 times 5 to get my area, 30. Again, it doesn't tell me units, so I'm just going to say units squared. If you would use the distance formula to find the length of the base and the height, you would have still gotten 6 and 5. All right, the next example, a trapezoid has these vertices, and angles A and B are right angles. So let's sketch it. Ooh, let me try that again. All right, A is at 5, 0. B is at 4, 3. C is at 10, 5. And D is at 8, 1. Ooh. Okay, and it says angles A and B are right angles. So I know that's a right angle and that's a right angle. What's the area of a trapezoid? So looking at the formula sheet, the area is 1/2 times the height times the sum of the bases. So the height would be the distance between A and B, and I can't just count the blocks here because it's not vertical or horizontal, so I'm going to have to use the distance formula. Base 1 would be AD, I'll need the distance formula there, and BC will be base 2, and again, I'm going to need the distance formula. So we're going to practice using the distance formula to find the length of AB, AD, and BC. Please do that now. Okay, so using the distance formula for AB, you should have gotten the square root of 10 Don't round it, just leave it, square root 10. For AD, again, we got the square root of 10. Now this is just a coincidence that they both happen to be the same. That will not happen every time. And BC, the length of BC is 2 root 10. So when I put that in my picture, AB is the square root of 10, AD is the square root of 10, and BC is 2 root 10. Now I have everything I need to calculate the area. The height is the square root of 10, base 1 is square root 10, and base 2 is 2 root 10. So I have, in the parentheses, I have 3 root 10. 1 root 10 plus 2 root 10 is 3 root 10. Just like 1x plus 2x would equal 3x. Well, the square root of 10 plus 2 times the square root of 10 is just 3 times the square root of 10. So now I have 1/2 times the square root of 10 times 3 times the square root of 10. Well, the square root of 10 times the square root of 10, you can think of it two ways. You can think of it as the square root of 10 squared, and the square root and the square will cancel. Or you can think of it as the square root of 100, because 10 times 10 is 100, and the square root of 100 is 10. Two ways to think about it, same answer. So now I have 1/2 times 3, and the root 10s canceled out the square root, so times 10. And now I can say 3 times 10 is 30. So the area is 15 units squared. That's my answer. That was pretty much it for 4.4. I know it felt maybe kind of short and easy. I could show you an example, a million examples, but the best way to get good at this is to practice. And there are some very good practice problems in the K-12 content. So if you haven't done those by now, please make sure you go back and review that content. Today's attendance word is height. The height of a figure is also called its altitude. I didn't mention that word really a whole lot today, but if you hear something called an altitude, it's talking about its height. Okay, so the attendance word is height. Spell it right on that attendance quiz. Have a great day, guys.